Today, I want to talk about an interesting paper about random forest for variable selection. The main methodological contributions are the following two. The first one is to provide some experimental insights about variable importance index of random forest. The second one is to propose a two-step algorithm for two classical problems. This is an overview of this paper. I will talk about the introduction. After the introduction, Guo Yi will talk about the variable importance of random forest, especially in the case that there exists highly related important variable. Section 3 proposes a procedure for two classical variable selection problems. Section 4 examines some experimental results. Section 5 open discussion about future work. Zhou Nan will discuss the section 3 to section 5. The first concept is random forest. Since we have discussed in our course earlier, so let's just briefly recall this full work about this topic. The second concept is variable importance. The most widely used one is increasing in mean of the error of tree. Let's consider the comparison between this definition and MSE is very similar. Well, for regression problem, there are three measures: departure importance, level importance, and theoretical importance. An extension to nonlinear regression, we focus on input and output analysis. A comparison between random forest and a linear regression based on importance index indicates that the results are in agreement. Finally, the first goal of this paper is to provide some experimental insights about the variable selection. The next topic is about the variable selection. Let's just briefly mention some variable selection mice. There are three types of variable selection mice: flitter, wrapper, and embedded. A typical situation is classification problem of highly dimension, which indicates n is much less than p. So there are lots of useless variables and unknown variables which are highly correlated. There are two goals of variable selection. The first is to find important variable highly related to the response variable for interpretation. The second one is for good enough prediction using the number of variables as small as possible. Now let's go in to continue to talk about the variable importance.
In this section, we examine the random forest variable importance behavior according to three different issues: the sensitivity to the sample size m and the number of variable p, the sensitivity to method parameters m_try and n_tree, presence of groups of highly correlated variables. And we need to do some preparation. We define the random forest variable importance of xj using this equation. N_tree is the number of trees of random forest. OOBT is the data not included in the bootstrap sample we used. We compute the error of a single tree T on this OOBT sample and the error of predictor T on the perturbed sample. And we used a simulated dataset for the case that m is much smaller than p, an equiprobable two-class problem with 6 true variables. And we will plot the results. The 6 plots on the left side illustrates the behavior of Vi of n and p. We can see that Vi is more unstable for huge values of p, and when p increases, the order of magnitude of importance decreases. The right plots about m_try and n_tree show that The magnitude of Vi increases when M trie gets larger, more than doubled, but the effect of entry is less visible. As for highly correlated predictors, after adding to the dataset simulated variables with variable 3, which is the most important one, we can see that VIs in the group 1, 2, 3 are steadily decreasing, while VIs in the group 4, 5, 6 are unchanged. Therefore, the importance will not be divided by the number of replications, and even if variables of low importance cannot be confused by noise. And next, Namzhou will talk about variable selection.
Next, I'm going to talk about the variable selection method proposed by this paper. There are two objectives of variable selection. One is to find all the important variables for interpretation. The other is to find a sufficient parsimonious set of important variables for prediction. This paper proposed a variable selection method based on random forest, which includes two steps. First step of this method is to rank variables by variable importance index mentioned before. Then, variables of small importance will be eliminated. The second step is to select variables for different purposes. For interpretation, a nested collection of random forest models starting from one variable to all remaining variables are constructed. The variables of the model having the smallest out-of-back arrow are selected. For prediction purpose, an ascending sequence of random forest models are constructed by invoking and testing the variables stepwise, which means that a variable is added only if the arrow decrease is significantly greater than the average variation obtained by adding noisy variables. The paper examined this method using the simulated dataset, which has been introduced and used in Part 2, Variable Importance. The dataset has 100 observations and 200 predictors. Out of the 200 predictors, only 6 are true variables, which means they are correlated with response. They are represented by these symbols in this figure. Other predictors are noise, which means they are not correlated with response. The top left graph shows the results of variable ranking. 50 most important variables are plotted in this graph. You can see that the top 6 are true variables, other noisy variables having an importance very close to 0. The top right graph shows the corresponding standard deviation of variable importance index. This graph is used to estimate the threshold for variable elimination. We can see that true variables' standard deviation is large compared to the noisy variable. So the threshold value is set based on the variable importance standard deviation, and variables with an average variable importance exceeding the threshold are kept. The bottom left graph shows the out-of-back arrow of the nested collection of random forest model. You can see that the arrow decreases quickly and reach its minimum when the first 4 true variables are included in the model. Then it remains nearly constant. So the final selected model containing 4 of the 6 true variables. The bottom right graph shows the result of variable selection for prediction. We can see that the out-of-back arrow reach minimum when the model involves 3 variables, which are variables 3, 6, and 5. The paper also examined the performance of this variable selection method in presence of several highly correlated variables. Highly correlated replications of variable 3 and variable 6 are added. The table shows the results of variable selection for interpretation and for prediction when respectively adding 1, 5, and 10 replications of variable 3 and variable 6 to the dataset. I superscript j indicates that variable I is a replication of variable j. From the table, you can see that the prediction results contain all variables of interest, which are consistent with the result obtained previously. However, the interpretation results do not contain all variables of interest. In conclusion, this paper proposed a random selection method using random forest. The performance of this method is quite good in high-dimensional data with highly correlated variables. However, for high-dimensional problem, the performance of variable importance is more sensitive to the number of variables selected and the number of trees. In addition, the paper mentioned that there is difficulty in analyzing the random forest from a mathematical point of view. In the discussion part, the author proposed two ideas about the variance of random forest. The first one is if pruning can be used for variable selection of random forest. The second one is about the random feature selection step. At the end of this paper, the author talked about the application of this variable selection method in fMRI brain activity classification, which is a situation of high dimension and have lots of highly correlated variables. Here are some questions raised for this paper. We would be pleased if you will participate in and provide your insights about these questions. Thank you for your attention.